Hello students, welcome back to a new series of mathematics program for grade 9. In this video, we are going to talk about the chapter Vectors and Translation. Well friends, today's session is the third part regarding this chapter. So let's start. In this program, you are going to learn what is meant by translation, how to represent a translation by means of a column vector, and finally, how to find translation vector when image and object are given. Students, remember, in the previous videos, we talked about vectors. And now it's time to talk about translation. Translation means moving an object from one location to another. It is done without rotating, reflecting, or resizing the object. Well, an example of translation in real life can be illustrated by the movement of a car from a point A to a point B. Now, if a point X is moved or translated to a point Y, then point X is called object and point Y is called image of point X under a translation. Next, we consider the line segment AB. Now, if this line segment is translated to line segment A', B', we say line segment AB is the object and line segment A', B' is its image under a translation. Suppose we express the vector AA' in column form. Notice here, there is no horizontal movement from the starting point A. Therefore, the horizontal component of this vector is 0. Next, we look at the vertical movement, which is 3 units upwards, implying the vertical component is 3. Similarly, we can express the vector BB' in column form. Here again, there is no horizontal movement, which means the horizontal component is 0 and the vertical movement is 3 units upwards. Thus, the vertical component is 3. Students, observe, the vectors AA' and BB' are represented by the same column vector. Therefore, vectors AA' and BB' are equal vectors. Remember, equal vectors have same magnitude and are in the same direction. Hence, a translation moves a point or a set of points from one position to another through the same distance in the same direction. Now, you are going to learn about translation vector. A translation is usually denoted by the letter T and represented by a column vector as T having components H and K, where H represents the horizontal movement and K represents the vertical movement. Students, remember, H is also referred to as the horizontal component and K is also referred to as the vertical component. Recall, horizontal movement can either be to the right or to the left. If we move H units to the right, then H is positive, while if we move H units to the left, then H is negative. Vertical movement can either be upwards or downwards. If we move K units upwards, then K is positive. On the other hand, if we move k units downwards, then k is negative. Students, now you're ready to learn about finding translation vector when image and object are given. In example 1, we have to find the translation vector t which maps point A onto point B. Remember, first we represent the translation t on the grid by a directed line segment from object A to image B. Next, we express the translation vector in column form by considering the horizontal and vertical movements starting from object A, which are 4 units to the right followed by 4 units downwards. Hence, the horizontal component is 4 and the vertical component is negative 4. In example 2, we have to find the translation vector which maps the line segment AB onto the line segment A dash B dash. Students, remember, a translation moves a point or a set of points from one position to another through the same distance in the same direction. So, in order to find the translation vector in case the object is a line segment, you can focus on the movement of any end point of the object. Suppose here we consider the movement of point A to A dash. Remember, first we represent the translation t on the grid by a directed line segment from object A to image A dash. Next, we express the translation vector t in column form by considering the horizontal and vertical movements from the starting point A, which are 4 units to the left followed by 2 units upwards. Hence, the horizontal component is negative 4 and the vertical component is 2. Friends, you can verify if this translation vector is correctly represented by just taking a look at the translation of B to B dash. Here again, the horizontal and vertical movements are 4 units to the left followed by 2 units upwards, implying this translation vector is correctly represented. In example 3, we have to find the translation vector t which maps shape x onto shape y. Students, in order to find the translation vector in case the object is a shape, you can focus on the movement of any vertex of the shape which is the object. Suppose here we consider the movement of vertex A to A dash. Remember, first we represent the translation t on the grid by a directed line segment from A to A dash. Next, we represent the translation vector t in column form by considering the horizontal and vertical movements from point A, which are 5 units to the left followed by 2 units downwards, implying the horizontal component is negative 5 and the vertical component is negative 2. Students, now it's time to take some exercises for practice which will definitely help you to understand better today's lesson. So take note, question number 1 and question number 2. Question number 3. To summarize, in this program you have learned about translation, how to represent a translation by means of a column vector, and finally, how to find the translation vector when image and object are given. Friends, here are some links which will provide you with additional information regarding today's lesson. So take note. Students, this video on vectors and translation ends here. Remember that this program was the third part regarding this chapter. In first and second parts, we talked about vectors. Today, you have learned about translation, representation of translation vector in column form, and how to find translation vector when image and object are given. In the next video, we are going to talk more about translation. So friends, till we meet again, it's a goodbye and see you soon.